Good morning, good afternoon, everyone. Thanks for coming out today. It's a pleasure to meet you.
Hello, I'm Lauren.
And I'm Jonathan.
We're from SAP, located in Boulder, Colorado. And we're pleased to finally get to share with you guys the lessons learned. Really?
Yeah, you go.
I can hear. We're pleased to finally get to share the lessons learned for migrating our Jenkins build system to Kubernetes. Getting Jenkins running in Kubernetes definitely broke our brains. You know, if we had heard this talk a year and a half ago, it would have saved us a lot of time and a lot of pain. We hope what you learned today will keep you from breaking your brain too.
Yeah, so before we get into what we're up to, let's learn a little bit more about you. So I'm going to ask for a bit of audience participation here. If you're from Seattle, if this is your hometown, please raise your hand. Let's see. Oh, thank you for coming. All right. Which is the best coffee? Is it Starbucks or Pete's or Intelligentsia or anyone?
None of the above.
Slate? None of the above? Okay. Come find me afterwards. I need to know which one's the best one. All right. Wait, hang on. We got a couple more questions. So, who is brand new to Kubernetes this year? Who's new? All right. Let's give these people a round of applause. Thank you for coming. Welcome to the community. You're making us all stronger. All right, who actually here is sitting in this room built part of Kubernetes? Anyone? Raise your hands. All right, look around, folks. No, keep those hands up. I see you. Everyone else see these people? That's who you need to talk to. They have all the answers. All right. So finally, let's talk about what we're going to talk about today. So first, we're going to tell you the story of the bad old Jenkins that we used to have. This is what led us to replace everything that we're talking about here today. Led us down this journey into Kubernetes. Then we're going to talk about the 3 easy steps. It was simple to get this Jenkins running on Kubernetes, obviously. And then what happened when we actually got it working, but then we needed to get the developers to work with it, and our early stages of getting it smoothly running into production. And if we're all done at the end, we'll leave some lessons for you and maybe some time for questions. So, all right.
All right, so we're going to start back in January 2017. We had ourselves a bad old Jenkins. Developers often referred to it as jerkins. We could never rely on it. It never ran the same way twice. Therefore, we couldn't be trusted. It couldn't be trusted. And our developers ended up ignoring it.
Right. It's like that day you have your low tire pressure sensor on your dashboard, and you just leave it there, and it doesn't seem to be any problem until one day you find yourself on the side of the road with a smoking tire, right? So Jenkins was always breaking. It was always breaking because the VMs that it was running on would just up and die. And then we'd try and bring those VMs back up, but we had this teetering pile of Chef scripts that was completely indecipherable. So we'd never get the same version of Java or the same version of Maven or the same version of MySQL running. And that made it super unreliable. And so every time we ran the build, sometimes it would succeed and sometimes it would fail, and we never knew if it was the build script or the machine that it was running on.
On top of that, our build scripts were nested within our Jenkins jobs, not versioned. We never knew what had changed, and we couldn't easily roll back. It would be really hard to roll back. This is the story of our bad old Jenkins. So I'm going to ask the audience, how many of you have a bad old Jenkins back in the office? Raise your hands. All right. Those of you who didn't raise your hands are probably lying. All right. Since Jenkins was burning up so much of our time, we finally decided to scrap it and build something new.
So, as we thought through what it meant to have a good Jenkins, we realized there really was one important goal to our effort, and that was to make it simple enough that our developers could manage it. Because we're the DevOps guys, right? And we just didn't want to be always answering questions from our development team. You know, why is this build broken? Why is this thing down? Why can't I? Could you please fix it? And so forth. We wanted Jenkins to be everybody's problem, not just our problem. So that meant that what we really needed to do was get the developers to manage their own build system so that Jenkins was their problem, right? But it also meant, and this is the important part, it was simple enough that they could do that, right? We need things simple for developers, bless their hearts. And so Yeah, so we needed things simple enough for developers, and so that meant that we actually had to take all that system stuff that is really complicated and simplify it and make it reliable enough that Jenkins would just work.
Also important, security. We needed to have it run on our corporate network. It needed to be free, so we're going to reuse the infrastructure we already have. And our Jenkins needed to be repeatable and efficient, so we can run more builds with the same infrastructure. Also, reprovision from scratch if it were to break. It needed to be fast. We wanted to get the build times down to 30 minutes, from 2 hours, 3 hours, to 30 minutes. So we picked Jenkins 2.0 and Kubernetes because it checked all those boxes, and because it's fashionable.
And because it's fashionable. Isn't that why we're all here anyways? It's fashionable. Way to go, Kubernetes. All right.
Awesome. We figured it would just take 3 easy steps, right?
Yep.
Just 3 easy steps. Prepare the VMs, prepare Kubernetes, and configure Jenkins. How hard could it be?
Oh, man. But remember, Kubernetes is open source. And so is Jenkins. So this is early 2017. It's Kubernetes 1.6 that we're trying to build this on, right? So there are lots of bugs, and there's very little documentation, right? And everything about Kubernetes today is much better. Everything about Jenkins today is much better, which is fantastic, because we were just barely Jenkins 2.0, barely able to run Kubernetes. There was no KAdmin when we started. It was too early for that. But what we did is we updated this talk. The lessons we're sharing with you today are for the latest Jenkins 2.0 and Kubernetes 1.12. So you can take what we've got today and actually apply it to your builds at work tomorrow or next week. I mean, we've got some drinking to do, right? All right. So
we suggest you check out our example repo. The scripts in our repo will enable you to set up a Jenkins on a Kubernetes cluster in just 20 easy steps. It includes our best stuff. 20 easy steps. Includes everything we described here today and several of the brain breakers we didn't have time to cover. Now, Jonathan, if we had these scripts 1.5 years ago, our brains would only be half broken.
that's true. So this is our gift to you. Only half break your brains. So here's what we started out with. We had some sort of common good developer services. So this is our Docker repository. This is our Git repository, corporate DNS, all of that stuff that we already had working. Then we had 24 Debian VMs running in our data center. And those are running our Jenkins master and our Jenkins worker nodes. And that's what we had for compute. And then, of course, we've got those developers with their laptops that have to use this. And so this is what we were going for, this is what we wanted to build. It was sort of, we wanted to continue to use those common developer infrastructure pieces so the developers could keep following their current workflow. But we wanted to take those Debian VMs, clean them off, get a Kubernetes cluster running on them, and install Jenkins on that. And so that is what we did.
So you recall those 3 easy steps, right? How hard could it be? This is when our brains really started to feel the pain. These are our top 3 brain breakers that popped up as we tried to build the Kubernetes cluster a year and a half ago. Let's go through these. Here's what we noticed. A VM would suddenly become unresponsive and completely unreachable. It couldn't even ping it responded. The VMs, why are they slow? Why are they hanging, right? This happened over and over again with no pattern, no reason. What could have happened? It must be the networking, surely.
Nope.
Disks full?
Yep.
Why are the disks getting full? What's going on here?
Yeah. Well, it turns out Docker and kubelet create lots of files on varlib. I see a few people nodding. You might have seen this before. All right.
Oh my God.
You know where we're going here, right? So they create all these files on varlib, and varlib usually lands on the root partition of your VM. And if you're using a VM, your root partition is probably really small and really slow. And so it doesn't take long to fill it up. And even if you ask for your people to attach a disk to it so you can have lots of space to run your builds, that's not going to get mounted by default. You actually have to do it yourself. So it's like you're driving a truck and all the freight is in the cab with you and the trailer is empty. So what do? Well, you have to mount and move. So first of all, you have to make sure that you mount that extra file system that got attached, the big, fast file system. And this shows you how to do that, the few Unix commands. And then you have to you have to set up the paths for Docker and for kubelet so that they land on that big file system. Here's a snip of code that shows how to do it with the symlink. I'm sure this isn't new to anybody. But that solved the problem for us, and we've got the whole thing scripted out in our repo, so go ahead and check that out if you're planning to do this yourself. Save yourself some brain pain. Problem solved.
So next, what's up with the networking not connecting, right? So at this point, we have our disk issue sorted out. Our capacity's looking good. And then we ran against this networking issue. What we saw was when Kubernetes tried to connect, what we saw is when Kubernetes was running, the nodes would never show as ready.
Right.
Okay, this is quite peculiar. This is where a VM can talk to a VM, but a kubelet cannot talk to a kubelet. A pod cannot talk to a pod. Our VMs were looking good. Our Docker daemons running. VMs could talk to each other. What's going on here?
I don't know. Let's find out. Well, it turns out the answer is in IP address ranges. So there are 3 private IP4 address ranges you can see here. And our corporate network was running on the one that starts with 10. And it turns out that kubeadm by default, yeah, I see some nods here, also runs on 10. And so you end up with a pod network running on the same IP range as your corporate network. And as you can imagine, if you're sending packets from one 10 dot address to another 10 dot address, it expects it all to be one continuous network range, and the packets get lost and the pods can't talk to each other and everything goes haywire. So it took us a long time to figure out that this was actually the problem, but it turns out the solution is pretty simple. You just pick a different IP address range from a different private IP network range, and then, all right, everyone got pictures? And then you pass it into the kubeadm init function. It's as simple as that. Problem solved. The Kubernetes cluster can come together.
Okay, now that we have a working Kubernetes cluster, the networking is running smoothly, the disks have plenty of capacity, but where should we put Jenkins home in this Kubernetes land?
Yeah. So Jenkins is old-fashioned. It expects to have a disk that it can rely on to put its files in and get them back. But the problem is now it's running in a pod, and a pod is not a VM. They don't have disks. So you have to set up a persistent volume to put that Jenkins home on, right? And that's fine if you're running in Google Cloud or Azure Cloud or any other managed Kubernetes because they've gone to the trouble to build persistent disks for you. But if you're running it in your data center on a bunch of machines that you scrap together, your options are pretty slim. So we tried a couple of different things. First, we had a complicated backup scheme involving init containers and Git repositories, and we could never get that to be really reliable. Then we tried a bunch of roll-your-own persistent volume things like Rook or Portworx or GlusterFS. And at the time, remember this is a year and a half ago, none of those were reliable, although we understand they're getting better. So if anyone here is from Rook or GlusterFS or any of those, thank you for doing the work. It's valuable. We want to see more. But here's what we ended up doing. We ended up using network file share. It's good old 40-year-old technology to the rescue here. What we did is we treated a single node in the cluster like an old-timey file server, right? So it mounts a directory, it shares it in NFS, then we can mount that using the standard Kubernetes stuff. The benefit is it is super simple and it is super stable.
It's been over 6 months. We haven't looked back. It's been stable. It's been great.
Yeah. Drawback is it's an old-timey file share. It's not redundant, and you just have to treat it as such. But good news, hey, guess what? We have 40 years of experience running these kind of file systems, so I think we can figure this out. So here's what you do. First step you see on the left, you pin your NFS server deployment to a particular node in your cluster. The second thing you do is you create a service and you have to give it a static cluster IP address. That's important because NFS doesn't talk host names. Yes. It only talks IPs. And then third, you provision a persistent volume referencing that cluster IP address. And voila, you have a persistent volume.
Okay. Now we're ready to move our Jenkins jobs into our new Kubernetes cluster. We have distilled our experience into these 2 recommendations for you. How and why to benchmark your disk subsystems and how and why your Jenkins should be repeatable configuration.
Yep.
On benchmarking, if you want fast builds, you're going to need fast disks. There are two important aspects for performance: throughput and IOPS. Throughput's how fast can you read and write one big blob of data? IOPS per second, is how fast can you read or write lots of tiny blobs of data. Your Kubernetes nodes must have fast disks that are at least as fast or faster than your old build system. Benchmarking is easy, and here's how. No software to install. You can use these simple Unix commands to benchmark your disks. We have this in our example repo. You can just paste this into a Jenkins job and run it, or you can run it on the command line. It's going to produce some numbers for throughput and IOPS that will help you build a better performant Kubernetes cluster that's faster than your old build system.
Yeah. It's really easy. It's worth the time.
Yeah.
Just do it. All right. The next thing is how do you make the Jenkins configuration repeatable? And we went through a lot of trouble with this, dealing with bugs in early Jenkins 2. A lot of those are shaken out, but we want to share 2 recommendations with you about how you can handle Jenkins configuration. Our first recommendation is this: just do the global Jenkins configuration through the Jenkins user interface, right? This is where you're on your laptop, you log into Jenkins, you go to the config screen, you install plugins, et cetera, et cetera, et cetera. All your changes get written to Jenkins home, and then you have a backup job that can keep that backed up, and you have a restore job that can bring it back when your cluster goes down, or if you need to move or reprovision or do whatever you need to do. The good news is, in the example repo, we have a backup job and a restore job baked into the Helm chart, and so if you just pull it down, you can see how that works, adapt it to your needs, and do whatever you want to do. It is way simpler than trying to figure out how to write all those groovy scripts to do what your admin UI can do in just a few minutes. Okay. The next thing we'd say is run your build configuration in Jenkins files and check those Jenkins files in with the code repo. That way, the developers really truly own their own build process, right? If the build breaks, they can log in, they can write code in the Jenkins file, they can write scripts, they can patch around, they can test out different build configurations on different branches. It's their problem, and they can have the tools at their disposal to just fix it. So that's what we did.
And then we let the developers drive it. So at this point in the journey, Kubernetes is running nicely. We have sample workloads going through, flowing.
Yep.
We're benchmarked our I/O, so we're performant. We've migrated our pipeline job over and brought our old bad Jenkins down, scrapped them. And now we're ready to turn it over to developers. And this is the point, like on Friday, we sent out a reminder email to all the development team. On Monday morning, when you come in, you're going to have a shiny new build system.
Yes.
So, Jonathan, we did it. We got through it. We got all our goals met. And then I'm going to show you what happened on Monday morning here. All right, there it goes. Ugh. All right, here we go. We're barely working. We're barely working. And if you see in the back there, that red shirt, that's Jonathan and I back there. We're putting some chains in the bus to get it out of the snow. We're fixing the engine. In the front of the bus there, you can see all the developers standing around with their hands in their pockets, staring at us. And you see that guy in the front with a crazy jacket? That's our UI developer.
That's Mike.
That's Mike.
Yep.
Hi,
Good old
Mike.
Mike.
Hi, Mike. All right.
All right. Well, this is when our brains really started to break because we didn't have a fallback plan. We had to move forward and solve these problems. So let's have a look at the top 3 brain breakers that happened once the developers actually started using this for real. First, intermittently failing builds.
Okay, you want to go back?
We're good.
Okay. All right. First thing we started seeing is errors in the log. Now, what the heck are errors? Does anybody know what an error is?
Oh, yeah. Someone shout it out for me. Out of memory.
A lot of people raised their hands.
Yeah.
I wish you guys were here a year and a half ago, could have helped us with that. All right, what we saw was unresponsive nodes, intermittently failing builds, pods randomly terminating with errors in the logs, and nodes were memory starved. Mm-hmm. What we first tried is adding more nodes. Did that help?
Nope.
Oh, wrong. Add more memory? Surely more memory is going to help this problem.
Nope.
How about throttle the builds? There are too many builds running at once.
Nope.
Oh. So what is the problem here?
So the problem is that Java doesn't play nice with containers. It just doesn't. All right. So, and how many of you are running Java workloads? Almost all. How many of you are running Jenkins? All right. If you're running Jenkins, you're running Java. Okay, just so we're all clear. If you're running Jenkins, you're running Java. All right. So what we saw. So let me pose a hypothetical. Here's what happens. Here on this screen is my little drawing, and you can see there's an 8 GB container running on a 16 gig machine, and in it we've got a Java process. And that Java process is working really hard. And so it's trying to allocate memory and allocate memory and allocate memory and keep up with all the tasks that those blessed developers have done for us. And eventually, it needs to allocate more memory. So it asks the operating system, how much memory do you have? And does anyone know how much memory the operating system tells it? All of it, 16 gigabytes. Yeah, so whatever your heap size is, it allocates 16 gigabytes. So if you don't tell Java how much memory it has, it's going to use up every byte of memory in your entire virtual machine. It completely ignores whatever limits you put on the container. And so if you've done your Kubernetes right, you've set limits on your pods. As soon as Java crosses over that 8 gigabyte limit, whew, bye, out of memory. All right. So yeah, Java has no respect. So what do you do?
It's disrespectful.
So disrespectful. So what do you do? Well, first of all, always, 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 always set container memory limits. Not just requests, limits. You want Kubernetes to kill your pods when they try to take too much memory. All right, always. If you aren't sure what I mean, come talk to me afterwards. Okay, second, always explicitly set the Java memory limit on the Java process. Always. Because that's the only way you can be sure it's going to stay within the memory limits of the container. I know that the Java folks have worked on all kinds of extra ergonomics and check the C group and blah, blah, blah. I don't trust any of that. Just set the memory limit. And that also means if you're running Maven or Ant or Gradle, you have to go dig through the documentation and find those environment variables so you can pass that information into those Maven, Gradle, other build processes as well.
All right, the next issue we ran into is dangling Docker berries. That's a pet name we came up with, all right? So this is where half of the cluster had full disks. Full disks. Didn't we already fix that?
I thought we already fixed that.
Seriously.
Is this happening again?
Okay, what was the real problem here?
Well, the real problem is this. When a Docker container exits, it leaves some stuff behind. It drops some berries on those partitions, right? And that includes volumes that maybe someone referenced. It includes images that you downloaded. It includes container layers, especially if that Docker image crashed. And so no matter how big your partition is, eventually these things are going to build up and build up and build up over time until your partition is full. So remember all those errors we were having earlier? That was just tons and tons of unused Docker layers left behind also. And so nothing will automatically clean this up for you. So what do you have to do?
Someone said it over there. All right. So some solutions are, what we ended up doing a year and a half ago is we installed a cron job to clean hourly. So we've created a script that looks for and removes dangling Docker berries.
That's right.
That script's in our repo. You guys can use it too. Also, we started monitoring our node partition usage. We're using Prometheus and Grafana, and we get alerts when things are getting full. So that's a big help. And there's something out there called kubelet GC. You should maybe have a look at that. Give it a try.
Yeah.
And some of the lessons learned are, if you got dangling Docker berries, prune them, because they will grow in your partitions, and I heard it can be quite painful at times.
Yeah.
All right, there we go. Some of you guys got that.
So now the builds are stable, but we're getting really long waits for our Jenkins workers. And we're wondering what we can do about that. Sometimes it takes like 4 hours for a build to start because the workers are all used. So we said, maybe we'll try a couple of things. We'll try throttling back the number of builds that run. That wasn't great. We tried to get the builds to run faster. That didn't solve the problem really either. So what did we do?
Well, we have this thing called pod Tetris, right? So this is how to lose at pod Tetris. If you notice, we have a 24-node cluster here, and we have one size pod for every step, every stage of the build. That's not a good idea. If you look at our pod count on the top left, you'll see we only have 23 pods running. And our cluster is 100% used. There's no more pods can be scheduled on there. So this may be only two developer pipelines running. All the other builds will be queued up. So we're going to show you how to win at pod Tetris right here. Okay? So this is, if you look at this picture, you still have 23 pods running. The cluster percent used is down to 30%. So what we ended up doing, I'll tell you, we profiled our build stages. We watched the stages run and identified how much CPU each stage need, how much memory, and we saw that some stages require very little resources and others required more. So we used the Kubernetes Jenkins plugin to define 3 pod sizes. A tiny pod for checking out repos or Slack notifications, a small pod for build stages like deploy, sonar, and unit tests, and then we have some large pods for some intensive end-to-end testing. So we declare these custom pod sizes in the Jenkins file in different build stages. The results were profound. We saw up to a 500% increase in our build rates per hour. We were able to run more pods in the same exact cluster, and the queuing went away. When a developer committed, within a minute, we were getting feedback, and the pipeline was running. It was brilliant. Additionally, if you're running in a managed cloud, this could save you a lot of money a year, too, because you don't need so many VMs. In a managed cloud, you might be getting charged for every millicore you use or every time you use more RAM. So this could save you money as well. You're going to get more yield out of your hardware. This is a big win for us, this pod Tetris. So we wanted to share that.
Yeah, it's worth it to try and figure this out. So finally, we have Jenkins all working. We got those short builds, they down from 2 hours to 30 minutes. We've eliminated our build queues. Developers get feedback right away. We can recover from a broken cluster within a day. The developers are starting to actually trust the build results. And we are free to work on other things.
And then it was a big takeaway for us that we had the same exact infrastructure we started with, the bad old Jenkins, the same VMs, right? And we got our builds faster. We were able to put more builds through it. And it was more reliable, repeatable, all the good vibes. It's because we moved our Jenkins into Kubernetes. We could run everything way more efficient. We could yield the hardware. It just, was it worth it in the end?
It was worth it, yes.
Yeah. But our brains...
Oh, they're definitely broken. Definitely broken. All right, so let's bring this home. So if you want to do this too, these are the 4 things you need to do. Number 1, benchmark your I/O performance. Make sure that your disks on your new system are going to be faster than the disks on your old system. Okay. Second, Jenkins files for builds. Get your developers to learn how to manage it themselves. That's what they need. That way, Jenkins becomes everybody's problem. And don't bother scripting the global config. It's not worth your time, and it'll slow you down. Third thing, play pod Tetris. This is worth your time. Get more builds through the same hardware. That's what Kubernetes is for. And fourth, don't try and build Kubernetes yourself. There's so many great options out there, including one from SAP that I get to tell you about now. Thank you for your patience. It's called Gardener. So here's Gardener. Ready? Gardener is an open source Kubernetes management tool from SAP. So if you are running Kubernetes in your organization and you need to supply lots and lots and lots and lots of Kubernetes clusters to different teams, this is a good solution for you. It gives you the ability, one dashboard for all of your Kubernetes clusters. It gives you user access control, so some teams can get on some clusters and other teams can get on other clusters. And it works on Azure, Google Cloud, AWS, and OpenStack, and I think Alibaba and a couple of others are coming soon. So that's that. There's a super cool architecture diagram that I'm going to skip right over because we have the Gardener guys here. Who's the Gardener guys? Where are you? Stand up if you would. Well, okay. Yeah, if you're here, go down to the booth. You can talk to them. There's another open source project called Kima.
But yeah, the Kima allows you to extend your Commerce Cloud with using microservices with Knative.
Yeah, all the buzzwords. And so let's see. Stand up if you're from SAP. You want to wave your hands at everybody. We got a couple of people from SAP here. There they are. If you want to talk to these folks, please go down to the booth. We're here. We're friendly. We like you. And SAP supports a ton of open source software, and we'd love to chat with you about that. So thank you all for coming. Are there any questions? We have a question here. We have a single Jenkins master.
Doesn't topple over?
No, we can handle it.
Repeat the question.
No, the Jenkins, we have one Jenkins master and it doesn't topple over under the load. All right, who else? Yes?
Repeat.
Were the Jenkins plugins affected by moving over to Kubernetes? Yeah, it seemed like the Jenkins plugins didn't really have any problems.
Oh yeah, all of our plugins work just the same. It was seamless. Yeah.
Yeah, we didn't have any problems with there. Other questions? Which hypervisor are we using for our VMs? That's a great question. I don't know. We get those from the corporation.
VMware?
Minnie built it. She can answer. Okay.
KDM. KDM's the answer. Our underlying VMs hypervisors.
KVM is the answer.
KVM.
Yep. All right. Other questions? Yes? How do we ID the network issue? We just were watching packet traces, man. It was brutal. Yes?
Why didn't you scale it up with the devs? Like, say, for like some projects, some devs are going to start using Jenkins 2.0 and then...
So why didn't we scale it up with our dev teams a little at a time?
Yeah.
So we did. We just had a couple of devs with really small new projects and one big old project. And the big old project was the real reason we were doing this. And the small new projects we'd moved over and they worked great. It was no problem at all. But then we got this big old project over with all these unit tests and system tests, and that's what really broke it.
By the way, copy Victrola underneath Macy's.
Victrola underneath Macy's. Thank you. Yes. Good. Yes?
What's your approach to profiling your individual build stages?
How do we profile the build stages? Okay, so here's what we did.
We also, the Grafana Prometheus thing.
Yeah, so we installed Grafana and Prometheus, and then we brought up the Jenkins pipeline in one browser window and the Prometheus pods in the other browser window, and then we correlated which stages were running in which pods and how much memory and disk they were using, and that's how we did it. It was painful too.
We used a little technology, and we actually also just watched the build too.
Yeah. All right, who else?
What image did you use for NFS?
What image did we use? Google Cloud 0.8.
For the pod that runs NFS server?
Yeah. Oh, man. I don't know, but it's in the repo. So if you check out the repo, you can find it.
Did you consider the Kubernetes plugin?
That's what we used.
That's when we did our pod test. Just we defined our different pod sizes with that. Exactly. Good question.
Yeah. Sorry, yes, Platcher. Yeah, we still use a Kubernetes plugin.
Yeah, this pipeline is still running today, running right now. So we use the Jenkins Kubernetes plugin. Yes.
No, but we should be. Okay. All right. Yes. How do you declare pod size? Let's take that one offline.
Yeah.
Yeah. Let's chat afterwards. Yes. Yes. NFS pod is tied to a single node, and a single folder on that node serves all the files. Yeah. Yeah, that was the. Did we consider local storage? Local storage doesn't quite solve the problem that we're trying to solve. It's close, but it's not quite a good fit. And we could talk about that a little more later.
How do you guys know that
How did we do the Jenkins upgrade?
Well,
Yeah, we bring it all down. We change the base image, and then we bring it all back up again.
so we update the Docker image that's pulled when we run.
Yeah,
So-
we don't need high availability.
Yeah.
I mean, if Jenkins has to come down for an hour or two in the middle of the day, it's no big deal for our developers.
Yeah.
All right, should we get off the mics?
Okay.
All right.
Next.
Do you have to manage complex RBAC?
No, no, that's mercifully that we don't have to do. All right, well, thank you all. We'll be hanging around right here. You can ask us all the questions. We'd love to chat.
Thank you, guys.
Thank you.
Thank you so much.